Now we'll discuss about the signs of tan theta is equals to b by a in different quadrants. As we know that there are four quadrants, first, second, third and fourth. Now we'll discuss about this tan theta which is equals to b by a in these four quadrants. Now for this, first we'll take x-axis and here we'll take it a y-axis here. Now we'll assume a point called p of a comma b in such a way that we will take the point perpendicular towards the x-axis and we'll take the point P towards the origin. And we'll take the distance from P to the x-axis as B and the point P to O we'll assume it as R. Now, the distance from P to A we'll assume it as B. The distance from the point P to the x-axis is known as B. When we join the point P to the origin, the distance we will call it as R, such that in triangle OAP by Pythagoras theorem, we can write it as OP square is equals to OA square plus AP square. That can be written as R square is equals to OA is known as A square plus AP is known as B, that is square. Then we will get it as R is equals to square root of A square plus B square. Now we'll discuss about this the behavior of A and B in the different quadrants. And tan theta can be written as the y coordinate that is known as b by x coordinate that is known as a. Then we'll get tan theta is equals to b by a. The theta is equals to getting this tan to this side, then we'll get it as tan inverse of b by a. So this tan inverse of b by a will behave in different ways in these four quadrants. If a is positive and b is positive, that is real part is positive and imaginary part is positive, then we can write it as theta is equals to modulus of b by a. And coming to the second one, if the real part a is positive and the imaginary part b is negative, then the argument of z is calculated by using the formula minus tan inverse of modulus of b by a. And coming to the third one, when the real part a is negative and b imaginary part is positive, then the argument of z is denoted calculated by taking the formula pi minus tan inverse of modulus of b by a. And coming to the fourth one, if the real part is negative and even if the imaginary part b is negative, then the amplitude of the complex number or argument of the complex number is calculated by using the formula minus pi minus tan inverse of b by